Let's begin with a fear. A fear that may seem strange to many today, but once was a part of the daily life of every architect and engineer. The fear of an unwanted drop of ink. The fear of a sudden shake of the hand. The fear of a single wrong line right in the middle of a skyscraper plan after weeks of non-stop work. In that world, a wrong line was never just a line. It meant tearing the paper, going back to square one, losing hours, days, sometimes weeks of effort. This was the world before the digital revolution. A world of massive drafting tables, oversized sheets of paper, heavy rulers, templates, sharp pencils, and blueprint prints. Blue sheets with a strong, unforgettable smell of ammonia that anyone who ever worked with them would remember. For life. Designing even a simple part could take weeks. And a small correction, everything had to be redrawn from scratch. No undo, no save, no backup. And that's when a big question slowly started forming in humanity's mind. Did our design speed really have to be slower than our thinking speed? Why should ideas get stuck behind walls of paper, ink, and human error? How could design be set free? I'm Hussein, and today we're diving into the story of another software, a story that forever changed the path of digital design. The answer didn't arrive with an explosion, but with a quiet revolution. A revolution that didn't take place in the glass towers of giant companies, but in small rooms, university labs, and even simple garages. A revolution called CAD, computer-aided design. But in the beginning, this revolution wasn't for everyone. CAD in the 1970s was a very expensive dream. Computers the size of entire rooms, limited processing power, and prices that today would be close to $1 million. Only organizations like NASA, giant automakers like General Motors, and military and defense industries could access this technology. CAD was exclusive. Digital design power was in the hands of very few. And right here, our real story begins. The story of people who believed design shouldn't be a luxury privilege. The story of those who said, if ideas can exist in the mind of any engineer, then the tools to realize them should be in that engineer's hands. At the center of this story stands a genius, a little eccentric, and far ahead of his time, John Walker. John Walker had a simple yet dangerous idea: to take CAD out of million-dollar rooms and place it on the desk of the everyday engineer. It was 1982. In a modest corner of a technology expo, something happened that few at the time realized the full significance of. The birth of a small startup called Autodesk. And the introduction of a software that wasn't meant to be just a tool, but a force that would forever change the power dynamics of the design world. AutoCAD. This wasn't just software. It was a statement, a manifesto of design freedom. And the story we are about to tell today is the story of that journey. From pen and paper to pixels. From simple lines to artificial intelligence. This is the story of the empire of lines. And if you're ready, let's start our journey from a time when nothing was certain. Part 2, Before the Storm. To understand exactly what miracle AutoCAD created, we need to go back several decades to a time when digital design wasn't even a recognized term, and computers were little more than massive calculators. The early 1960s, an era when the space race between the US and the Soviet Union was at its peak, an era when MIT had become the beating heart of innovation and genius. And in this environment, a remarkably different young man stepped onto the scene, Ivan Sutherland. Sutherland had a simple yet revolutionary question. Why should a computer only calculate? Why couldn't it see, draw, and interact with humans? In 1963, he provided his answer, a system called Sketchpad. Today it might seem simple, but imagine, for the first time in history, a human being could use a light pen to draw lines directly on a screen, create circles, construct geometric shapes, move them around, resize them, and the computer could understand these changes. This wasn't just an improvement, it was a quantum leap. Sketchpad became not just the foundation of CAD, but the godfather of all modern graphic software. From AutoCAD and Photoshop to operating system graphical interfaces, and even video games. But like many great inventions, there was a major problem. The computer Sketchpad ran on, called the TX2, was nearly the size of an entire room, extremely expensive to maintain, and despite its grandeur, its processing power was less than the cheapest modern smartphone. CAD had been born, but in a golden cage. Beautiful, powerful, and completely out of reach. The 1970s were a decade of exclusivity. Computer-aided design slowly entered large industrial companies. Here, another name entered the history books, Dr. Patrick Hanratty. Hanratty, often called the father of CAD and CAM, wrote the first serious code for commercial design software and laid the foundations for systems like ADAM. These systems were astonishing for designing rockets, aircraft, complex engines, and industrial production lines. But a simple question remained: the price. Each CAD workstation easily exceeded $100,000, which meant that for an architect with a small office in an ordinary city or a mechanical engineer in a local workshop, CAD was like a science fiction dream. These tools were built for industrial elites, not for ordinary engineers, not for those working with their hands, not for the blue-collar workers. But history never stays still. In the early 1980s, the ground began to shake. Personal computers entered the scene. Machines like the Apple II and Commodore 64. Smaller, cheaper, and accessible to ordinary people. But what was the engineering community's reaction? Almost none. Many engineers at the time thought these were expensive toys, good for play, or at best, for writing letters. Not engineering tools, not professional design tools. And here, a huge gap emerged between CAD's extraordinary power and an ordinary engineer's ability to afford it. The industry was thirsty for a savior, a smart software that could do the same complex work, but not on million-dollar machines, on a personal computer instead. And this is where our story's hero entered the scene. Across the US, a clever, unique, and slightly different programmer saw this gap. He realized that if he could take CAD out of huge rooms and $500,000 machines and bring it to the democracy of personal computers, he wouldn't just become rich, he would change the course of history. His name was John Walker, and his idea was dangerously simple: CAD for the people. But this wasn't a solo mission. Our story is about a team of 16 rebels, people who came together not just to write software, but to break a monopoly and rewrite the future of design and software. And this is where the storm truly begins. Part 3, the 16-person garage. John Walker was no ordinary programmer. He wasn't the type to quietly follow Silicon Valley rules, build a resume, and wait for big companies' approval. Walker was, by nature, a rebel, a programmer with an economic mindset, an innate entrepreneur, and, most importantly, a visionary who understood long before anyone else that the real power of computers lay not in large corporations, but on the desks of ordinary people. In the early 1980s, John Walker began writing a document that may have looked like a personal note at the time, but would later become one of the most famous papers in computer history. Information Letter HAMP 14. This document was not a business plan. It wasn't a financial roadmap either. It was a manifesto. A manifesto about a dangerous idea. Software shouldn't only be sold to companies, it should go directly to the end user. To engineers, architects, designers, students, to the people. With this vision, Walker started assembling a team. Not necessarily the most famous, but the smartest. People willing to take risks, pull all-nighters, and work on an idea that didn't yet have a clear shape. Eventually, the group grew to 16 people. 16 who would form the core of a newly founded company, Autodesk. And here, the story gets a little ironic. In the early days, the team didn't exactly know what they were going to build. Autodesk existed, but the final product didn't. They experimented with various ideas, document management software, database tools, and other diverse projects. But among all these scattered paths, one idea slowly began to shine: design software for personal computers. And at this point, the second key character enters the story: Mike Riddle. Riddle was a quiet, low-profile programmer, but with a very precise mind. He had previously written software called MicroCAD, later also known as Interact. Simple, yet smart software that ran on older CP/M systems. When John Walker saw Riddle's code, he recognized something many had overlooked: potential. This code could become the core of a big dream: CAD for everyone. So Walker and his team made a critical decision. They purchased the rights to Riddle's code, and in return promised him a share of the software's future profits. A real gamble for both Walker and Riddle. But buying the code was just the beginning. The main challenge was this: the software had to run on the IBM PC. A new platform with DOS as its operating system, and limitations that are almost unimaginable today. Personal computers at the time struggled with severe RAM shortages. Previous CAD software ran on massive mini-computers, but AutoCAD had to survive in a space barely enough for a few simple programs. In simpler terms, the 16-person team had to rewrite MicroCAD almost from scratch. Optimize it, lighten it, and turn it from an experimental tool into a serious engineering tool. Months of round-the-clock work, code that crashed repeatedly, ideas that failed, systems that froze in the middle of work, but they never gave up. Alongside this technical brilliance, Walker made a bold economic decision, a decision that shook the industry. The price. Not $100,000, not $10,000, about $1,000. A price that, until that day, was almost unimaginable for CAD software. And the result? Suddenly, small engineering offices, independent architects, students, and even personal enthusiasts could own CAD. It was no longer a government or military tool. It was a personal tool. AutoCAD was born. But a big test still lay ahead. An exhibition in Las Vegas. A place where this software would have to prove its real power in front of a skeptical industry. The moment of truth. The final test for the 16 people who had bet all their assets, reputation, and future on a seemingly crazy idea. If you enjoyed this video, please give us a like. Your support helps us continue creating more content and sharing exciting stories with you. If you don't want to miss any of our upcoming videos, be sure to subscribe and hit the notification bell so you'll be notified as soon as we release new content. Also, if you have any experiences or memories related to this topic, we'd love to hear from you. Share them in the comments below. We can't wait to read your stories. Part 4, The Big Bet, Comdex 1982, November 1982, Las Vegas, USA, a city famous for spectacle, risk, and gambling, and perhaps no place was better suited for John Walker and his team's big bet. Comdex was the most important technology trade show of its time, an event where the future of the computer industry was shaped every year in its crowded halls. Thousands of companies with flashy booths, dazzling lights, and grand promises about the future. For many, Comdex marked the end of a work year. But for John Walker and the 16, it wasn't the end, it was the beginning of a real battle. They were facing industry giants, companies with multi-million-dollar advertising budgets, professional sales teams, and years of market credibility. And what did Autodesk have? No money, no huge booth, no well-known name, just one weapon, a piece of software, AutoCAD 1. But their strategy was smart and daring. While the big CAD companies set up their booths in specialized, closed-off engineering sections, Autodesk decided to stand right in the middle of the crowd, amid the flow of everyday people. They weren't looking for CEOs. They weren't looking for big corporate contracts. Their target was clear: real engineers, architects, and designers. When the AutoCAD demo began, something happened few had expected. People saw a real CAD software, with the same capabilities that until yesterday ran only on $100,000 systems, now running on an IBM personal computer. Not in a lab, not in a stage demo. Real, live, right in front of everyone. And the price? Less than $4,000 for the entire system, including the software. For many, it seemed like magic. AutoCAD not only ran, but ran fast. Lines were drawn, edited, zoomed in and out, all on hardware that until yesterday nobody imagined could do such things. This was not just a technical victory, it was a complete defeat for the old industry assumptions. Hardware companies realized one by one, if they wanted personal computers to enter engineering offices, they needed to sell AutoCAD with them. AutoCAD, from a newcomer software, became a PC sales catalyst. By the end of Comdex, John Walker and his team knew one thing for sure: they had won. Not by directly fighting the old CAD giants, but by changing the playing field. This wasn't a top-down revolution, it was a bottom-up revolution. Ordinary engineers, by buying AutoCAD, showed the companies that the future belonged to personal computers. And the result? Autodesk, in an astonishingly short time, grew from a small startup to the fastest growing software company in America. In the years after Comdex, thousands of AutoCAD copies were sold, and the software quickly became the unofficial standard in design. But this was just the beginning. Early versions of AutoCAD, with a black screen and a rigid command line interface, were still far from user-friendly. To maintain this position, Autodesk had to develop continuously. It had to prove that this success was no historical accident. And now, it's time to enter the heart of the story. Let's take a fast journey through AutoCAD's history to see how, over more than 4 decades, this software evolved from a simple line drawing tool into a global engineering platform. In the next part, the pace picks up, the visuals come alive, and the evolution unfolds right before our eyes. Part 5, A Journey Through Time, AutoCAD's revolutionary timeline. Victory at Comdex wasn't the end of the story. In the ruthless world of technology, no triumph lasts forever. If AutoCAD wanted to survive, it had to evolve faster than its competitors. Not one step a year, but a leap with every release. So buckle up, and let's take a rapid journey through time. A 40-year journey through the most important versions that transformed AutoCAD from a simple drafting tool into the backbone of the design world. The beginning, AutoCAD 1 to 2. The early versions, if you saw them today, might look almost laughable. Just a few basic commands. Line, circle, arc. No offset, no trim, no fillet. Made a mistake? You had to type long DOS commands to delete it. No Control-Z, no mercy. Yet despite this simplicity, AutoCAD was a miracle. A speed that paper and pencil could never match. For the first time, engineers felt that a computer could keep pace with their thoughts. Programming revolution, AutoCAD 2.1. Here, the real turning point happened. The introduction of something that would forever change AutoCAD's destiny. AutoLisp, an internal programming language. Suddenly, users were no longer just consumers. They could write commands, create macros, automate repetitive processes, and shape AutoCAD to fit their own minds. AutoCAD evolved from a software tool into a fully extensible platform. And this decision ensured the loyalty of millions of users for decades. The DOS legend AutoCAD R12. Ask a veteran engineer, what was the best AutoCAD ever? Often, with a nostalgic smile, they say, R12. A fast, stable, and surprisingly flawless version. Dialog boxes were practical, the command line lightning fast, and everything worked exactly as expected. R12 was AutoCAD's peak in the DOS era, a version that remains legendary to this day. Goodbye DOS, hello Windows, AutoCAD R14. The big transition arrived. Windows 95 had changed the world, and AutoCAD couldn't fall behind. R14 was almost completely rewritten. The text-based environment gave way to a full graphical interface, windows, icons, menus, and most importantly, high speed and remarkable stability. R14 laid the foundation for modern AutoCAD. The new millennium, AutoCAD 2000. Users wanted something simple. Why couldn't we open multiple drawings at once? AutoCAD 2000 answered. MDI. Multiple document interface. No more closing one project to open another. Copying, moving, and comparing drawings became dramatically easier. User productivity jumped significantly. Serious 3D, AutoCAD 2007. Until then, 3D in AutoCAD wasn't taken very seriously. But in 2007, everything changed. A stronger rendering engine, new modeling tools, and a real 3D experience. AutoCAD was no longer just a flat drafting desk. It became a spatial modeling tool and cemented its position against competitors. Parametric constraints, AutoCAD 2010. AutoCAD began to think. With the introduction of parametric constraints, drawings were no longer just a set of fixed lines. Relationships were defined. Changing the width of a space, walls, openings, and dependent components adjusted automatically. This feature transformed accuracy, speed, and control in complex designs. Connecting to the cloud, AutoCAD 2013 to today. In the last decade, AutoCAD moved beyond the personal computer. Cloud storage, mobile and web apps, access from anywhere in the world. The design office connected to the construction site. Drawings were always accessible. And today, AutoCAD is no longer just a drafting software. With specialized architecture, mechanical, electrical, and surveying toolsets, and AI-assisted automation of repetitive tasks, it remains the cornerstone of the design world. This rapid journey shows how software born in a garage fought technical and economic challenges and became a global standard. But AutoCAD's real legacy isn't just in its code and updates, and this brings us to the final chapter of our story. Part 6. The Legacy and Changing the World. AutoCAD was not just a successful software. AutoCAD was a proof that great powers could be taken out of monopoly and put in the hands of millions. But the real legacy of AutoCAD goes beyond commands, versions, or technical innovations. Its legacy is the transformation of the world we live in. The first, and perhaps most important legacy of AutoCAD is 3 simple letters. DWG. Drawing. A file format that gradually became the universal language of engineers and architects around the world. It doesn't matter if you are in Tokyo, or New York, Dubai, or Berlin. If you send a DWG file, everyone immediately knows what it is. DWG became an unwritten but unbreakable standard, a language that forever guaranteed communication across global projects. Now, Take a moment and look around you. Bridges, towers, airports, factories, even the tools you use every day. Many of these structures would never have been possible without the precision, speed, and repeatability of AutoCAD. Manual drafting would have taken years. But with CAD, the same complexities were designed in a fraction of the time. From seemingly impossible curves in modern museums, to ultra-precise structures of space stations, from industrial production lines to the tiniest components in your car engine, AutoCAD and the CAD principles it established are at the heart of it all. AutoCAD was not just a tool, it was a super tool. A tool that gave wings to engineers' creativity. Of course, history never stops. Over time, new competitors entered the field. Software like SolidWorks for mechanical design or Revit for building information modeling, BIM. These tools, with a focus on specialized domains, achieved significant advancements and, in many projects, became better choices. But the key point is, even these powerful competitors stand on the foundations that AutoCAD built. AutoCAD was the first software to democratize digital design on the personal computer. It proved that real power is accessibility. That is why we can say AutoCAD is the godfather of today's digital design world. And now we stand at the threshold of a future where the boundaries of CAD are shifting again. Virtual reality, augmented reality, and artificial intelligence entering the design process have changed the face of this world. Design is no longer just drawing a line, no longer just giving commands. Today, design is letting the computer generate thousands of solutions, simulate and suggest the best ones. But with all these advancements, if we go back to the roots, everything comes down to one point. To those 16 people, to a garage, to a simple but daring idea. They proved that real technology is not the one that centralizes power, it's the one that breaks monopoly. They didn't just make software, they redefined engineering forever. And this is the true legacy of AutoCAD. We began our journey at crowded drafting tables, where a single wrong line could erase weeks of work, and we traveled into the world of pixels, digital processing, and big data. This is the story of CAD and AutoCAD, a story that proves even the most complex projects can be accomplished with a bit of ingenuity, an affordable personal computer, and a bold idea. Technologies change, tools get more advanced, but one thing always remains constant: human creativity and the engineering mind. AutoCAD didn't just sharpen our pencils, it made our hands more precise and allowed us to turn our dreams into reality. If you have a memory with AutoCAD, if you've spent long nights listening to the command prompt, or remember the first time you rendered a 3D design, share that memory with us. If you enjoyed this deep dive into the heart of engineering, help us by liking this video so these important stories reach more people. And if you don't want to miss any of our upcoming videos, make sure to subscribe to the channel and hit the notification bell. Don't forget to tell us in the comments, what was the very first project you designed with AutoCAD? We're truly looking forward to reading your stories. Thank you for joining us on this epic journey. Until the next story, keep designing with power.